Hi guys, welcome to my channel. So from today I'll be starting a series on data structure. So in this series I'll be covering 15 to 20 problems on every data structure that is very important with respect to your coding and interview round question in a big tech company like Microsoft and Amazon. So let's just start with the very easiest data structure, that is array. So the very first question that we're going to see is that how to reverse an array. So here is our input array, that is A. Size of an input array is 6. So after reversing, our output array should become 6, 5, 4, 3, 2, 1. So before watching the solution, I'll just recommend you to please think and try to build the logic of this problem. If you'll not get it, that's okay, but at least try, okay? So the very first approach that we're going to see is by using naive algorithm, which is very simple algorithm. So this is our input array. Let's just say size of an input array will be 6. Let's just store the indexes 0, 1, 2, 3, 4, 5. And in this naive algorithm, we'll use an auxiliary array which size will be equals to our input array, that is 6, and type will also be equal, that is our input array is of type integer. So the type of our auxiliary array will also be integer. Let's just name our auxiliary array as B, and we'll just store our first element of an input array in the last index of our auxiliary array. So like this, we'll store our whole input array in a reverse order in an auxiliary array, right? So input array. So this is how our naive algorithm work, where will be so this is how our naive algorithm work, where we will be storing elements of our input array into our auxiliary array in a reverse manner, and at last I'll be I'll be copying the elements of our auxiliary array back into our input array. So let's just see the pseudocode of this algorithm. So this is our pseudocode of the previous approach, that is naive algorithm. So this is the pseudocode of our previous approach that we have seen by using naive algorithm. So at the very first line, this is the initialization of our auxiliary array, that is B. So this is our B and this is our input array, that is A. So the size of our input array, that is A dot length, will be 6. Okay. So we'll iterate through this input array one by one. Let's just store the indexes 0, 1, 2, 3, 4, 5. Here I am showing the last index. Okay, so when I is 0, so our A of 0 means 1 will be stored into the 6 minus 1 minus 0. So our 1 will store into our last index of our auxiliary array, that is 0, 1, 2, 3, 4 at the 5th index of our auxiliary array. So like that only 2 will be stored here, 3 will be stored here, 4 will be here, 5 will be here, and 6 will be here. So at last we'll get our reverse array, and we'll just copy by this line, and we'll just copy our auxiliary array back into our input array. Okay, so we'll get our reverse array. So let's just check the time complexity of this solution. So the time complexity of this solution will be O of n, because we are iterating to the input array, right? And the space complexity of this solution will be O of n. Why? Because we are using auxiliary space here. Okay, we can optimize this approach by using in place implementation, where we will not be using any auxiliary space. So let's just see how we can do this. So here is our input array 5 and 6. Let the indexes will be 0, 1, 2, 3, 4, 5. Here I'll be using 2 pointers, that is low, that will point towards the first element, and the high, that will point towards the last index. So whenever our low is less than high, that is our high is now 5, low is 0. Okay, so low is less than high, so we'll just swap low and high. So 1 and 6 will be swapped, 6 will be here, 1 will be here. Okay, then again we'll just increment the low by 1, so low will be here now, and we'll just decrement a high, so high will be here. Then again low is less than high, so we'll just low is now 5, so we'll just swap low and high, so 5 will be here and 2 will be here. Then again we'll just increment the count of low, and then again we'll just decrement high by 1. Now also low is less than high, so we'll just swap low and high, so 4 will be here and 3 will be here. Then again I'll increment the count of low and will decrement the count of high. Okay, so here you can clearly see that our low, that is at 3, and our high is at 2, so this condition become false because our low is now greater than high, so we'll not swap it. So here I have got my reversed array by using optimized solution. So let's just check the pseudocode for this. So here is our pseudocode of the previous approach by using 2 pointer, low and high. Okay, so low is at 0 and high is at a dot length means n only, that is length of an array 5, 6, 6. 5 will be n minus 1. So a dot length will be 6. High will be at last index, and this is our condition. Whenever the low is less than high, then we'll swap and we'll just increment the count of low and high. So 6 and 1 will be swapped, 5 and 2 will be swapped, then 4 and 3. So here I got my reverse array. So let's just discuss the time complexity. So time complexity of this solution will be O of n because we are iterating through this array once. Okay, and the space complexity will be O of 1 because we are not using any auxiliary. That's it. Hope you like this video. Make sure you like, share, comment and subscribe to the channel and hit the bell icon for further notification. So till then, bye. See you in the next video.